In this video, I'll present a method based on geometry, which allows us to calculate the limit of sine of x over x when x goes to 0. This method is the result of trying to come up with a formula for the area of a circle, based on the formula of the area of any polygon with equal sides and inside a circumference. Many students of calculus make the mistake of applying the L'Hopital's rule when they try to calculate the limit of sine of x over x when x goes to 0. To apply the L'Hopital's rule means to calculate the derivative of sine of x and also of x. This results in 1, which is correct, but there's a catch. The derivative of the sine function implies that 1 is the limit of sine of x over x when x goes to 0. This is circular reasoning, so this approach is not correct. Pi is the relation between the perimeter of a circumference and its diameter. The method I use to calculate pi is similar to the one used by this gentleman in the picture. His name is Archimedes. I use polygons with equal sides inside a circumference, and gradually increase the number of sides of the polygons. Using a limit to infinity, one can calculate with accuracy the area of the circle. In the end, I came across an indeterminate form, that is, pi is equal to infinity times 0. In order to calculate the area of a circle, one is going to use a pentagon inside a circumference. To calculate the area of the pentagon, one draws two lines. One from the center to the middle point of the side, and another which is the radius of the circumference. The result is a right triangle. One can identify a hypotenuse R, two legs H and A, and an angle alpha. Using basic trigonometry, one can write the equations using sine and cosine. Sine of alpha equals A over R. Cosine of alpha equals H over R. Alpha is equal to 36 degrees. Rearranging the equations, A equals sine of alpha times R and H equals cosine of alpha times R. The area of the pentagon is equal to 1/2 times the perimeter of the pentagon times H. The perimeter is equal to 10 times A. One substitutes the perimeter in the equation on top by 10 times A. The area of the pentagon is equal to 1/2 times 10 times A times H. Substituting H and A in the equation on top by the equation below, one gets area of the pentagon equals 5 times R times sine of 36 degrees times R times cosine of 36 degrees. So, the conclusion is that the area of any polygon inside a circumference and with equal sides is represented by the equation number of sides times sine of alpha times cosine of alpha times R squared. Alpha is equal to pi over the number of sides, and pi equals 180 degrees. Now one can calculate the area of the circle. The circle has an infinite amount of sides. The area will be equal to infinity times sine of pi over infinity times cosine of pi over infinity times R squared. Everyone knows that the area of the circle is also calculated by multiplying pi by R squared. So infinity times sine of pi over infinity times cosine of pi over infinity must be equal to pi, because the area of the circle is equal to pi times R squared. That is, pi equals infinity times sine of pi over infinity times cosine of pi over infinity. Pi over infinity equals 0. Pi must be equal to infinity times sine of 0 times cosine of 0. Sine of 0 equals 0 and cosine of 0 equals 1. Finally, pi equals infinity times 0. And as one knows, that is an indeterminate form. Another way to prove that the limit of sine of x over x when x goes to 0 is equal to 1 can be done using the geometry of a circle we demonstrated before. Using the formula for the area of polygons with equal sides n instead of circumference, one can extrapolate the formula for the area of a circle. In order to calculate it, one must use the limit to infinity. The result is an indeterminate form, that is, infinity times 0. To solve this, one must follow the following steps. First, one has a limit of s to infinity of s times sine of pi over s. One puts s in the denominator of sine of pi over s so that the limit becomes sine of pi over s over 1 over s. Next, one multiplies by pi over pi. This doesn't change the value of the limit. One puts one pi outside the limit and the other pi in the denominator. This allows us to have the argument of the sine function equal to the denominator. Finally, one substitutes pi over s by x. The limit of s to infinity of pi over s is equal to 0. Thus, one substitutes pi over s by x in the limit of sine of pi over s when s goes to infinity. The limit becomes sine of x over x when x goes to 0. One must remember that there is a pi multiplying the limit outside. So the limit sine of x over x when x goes to 0 must be equal to 1, because this limit represents the value pi that multiplies r squared. In the equation, area equals pi times r squared. So the conclusion is that the limit of sine of x over x when x goes to 0 is equal to 1.